All right, everyone, if you can take your seats, we're about to get started with the next talk. All right, and I'm sorry we don't have a second mic. That had to go upstairs to the second track, so I guess I'll have to yell, which is no problem. Raise your hand in the back if you can hear me. Awesome, thank you, thank you. So I'd like to introduce our next speaker. His name is Tal Melamed, and he's speaking on event injection, sending evil to the cloud. So Tal, thank you. Take it away.
Thanks a lot. Hi everyone, thanks for coming. Just checking, can you hear me well? Yeah. All right. So a few questions. How many of you here heard my talk last year? Okay. I just want to know how much stuff I can repeat. Joking. Yeah, so my name is Tal. I'm originally from Israel. I live here in New Haven, Connecticut. This is the second year for me. Not looking forward for the winter to come. It's been tough. Again, thanks for coming. I'm going to talk about this talk is going to be fairly technical. Another thing that I would like to know to tell you is that if any of you attended DEF CON and seen my talk there, it's going to be pretty similar. So if not, you're welcome to stay now that we've established that. Okay, just a word for the new guys here. So I want to thank Brian again for his keynote. It was great. And I just want to tell you that from my personal experience, that's exactly right what he said. I remember 3 years ago, September 3 years ago was my first talk at a local event, OWASP local event in Israel, and I did it the first time. I was nervous and I liked it. And 3 years after that, then I started, of course, with some other local BSides and OWASP meetings. And now 3 years after, I'm giving around this topic, these talks at Black Hat, RSA, DerbyCon, and then I just want to tell you guys that are studying up now, don't be afraid, go and try, and if you like it, I'm sure you can grow and do great stuff. All right, so I'm working at a startup based in Israel called Protego Labs. What we do is we provide a serverless security solution. If you like it after the talk, you're more than welcome to to come and catch up with me. So here are my, if you want to find me over LinkedIn or Twitter or whatever. I'm also teaching at Quinnipiac University in Hamden, Connecticut, at a master's program there. It's 100% online, so if you want a master in cybersecurity, also come talk to me after this talk. All right. We covered what we needed. Now what we're going to talk about is just a little bit about the technology itself, because serverless is quite new. So I'm going to just introduce you to the technology. And then we're going to have some fun with the fun part where I do a lot of damage in the cloud, mostly AWS, but it could be any cloud provider. And we'll see, I'll introduce you to some work that you can work with or you can get to know to practice yourself. And then if we have some time, then some Q&A. All right. So Basically, what we know today is that most companies or organizations, even the governments, most governments and secret services, everyone is going to the cloud. So pretty much the cloud now is the new OS for us. We don't need to take care of everything, of all the infrastructure. We don't have to take all the heavy lifting of building and connecting stuff. We can just use resources that are ready and secure and good to go. And in serverless, the idea is that it was meant for developers, basically. It gives them the power to just go ahead, develop features, develop the logic of the application, and not think about servers and how they have to manage them and configure them. So this is all taken away. Also, in serverless technology, everything scales up automatically, so it's transparent. It doesn't matter if your application hits 1,000 requests per second or 10 requests per week. It automatically scale up and down by the cloud provider. Also, very good thing, the pricing model is that you don't pay for what you don't use. So even if you want to build something and you're not sure anyone is going to use it, you can just build it, just go ahead, write code in the cloud, and if no one uses it, or if it being used very lightly, you don't pay for anything. So basically you just pay for what you use, and if you build even, we have some customers that have like internal IT or automation services that barely run like once a day, like a nightly build or whatever. They don't pay for that. Even though it runs in the cloud and they use a lot of services, they pay, like, it's insignificant, like under $1. And also, you get the availability and resiliency of the cloud. So whenever you deploy something, it is populated in AWS or the cloud provider's data centers across the regions that you have. So you have all the power of the cloud. Okay, what are the security challenges? Is that so I chose 4, but which will make the hacker's life easier, or give them the opportunity. So the first one, top left, is that in serverless you have to give a specific permission or policy for each of the functions that you build. So think about it. It's very, very good in the AppSec world. If you can take every 10, 100 lines of code and tell them, oh, this function which always writes to the database can only write to the database and only this database. And you don't have to make sure that it's enforced by the cloud. You just have to choose the right policy. But the problem is that AWS, for example, have more than 5,000 different actions that you can choose from. So, yeah, you can do it for 1 or 2 functions, 3, 4, maybe if you are doing it for yourself. But if you're a bigger organization and we have customers with thousands of functions, how do you do that? It's very difficult, and they end up not doing it right. Like, what happened is actually that the developer goes to a Stack Overflow, copy-paste the first example that works, and they stay with it. And this is what will eventually lead up to some damage in the cloud in case of an attack. Also, top right, it's your left. Okay, so top left, you have that in serverless, we lose the perimeter. So in the traditional monolithic application, we usually have just one way in. So it doesn't matter what protocol, usually HTTP or HTTPS, but it can be any, I don't know, TCP, IoT related traffic, but it's usually just one way in to the DMZ, to the load balancer, to the firewall, whatever you have there. And you put all your security controls in that place. So you monitor, you put firewalls, DLPs, or whatever you want, and everything that comes in and goes out is being scanned or checked. So sometimes we're lucky, sometimes less, but we have some security control on that barrier to check that. And we're going to lose that now because in serverless, the technology really is an event-driven architecture which runs codes based on events that happen in the cloud. It could be file upload, file download, change in a database, an IoT device connected, whatever you can think of. Email was sent, and so on and so on. And the problem is for the developers, for the organization, is that there are quite a lot of resources that they have to connect together and make sure that they have the entire security, access control, and everything configured right. And it's kind of a problem because it's not one server that you can just deploy, make sure it does the right things, maybe put some things before they hit the server. No, it's different resources, unconnected, that you somehow put arrows between one another or connect the dots, and you have to make sure the security stays. And it updates a lot, so it's very hard to keep up. So, okay, so I like to think about the regular traditional application as the football fields. The New England's here, they have to defend the incoming attack, and you always have the line of skirmish, and you have always the internal network is always 10 feet away. You know what you're protecting, and you put all your security controls in line against the incoming attack. So most of the time, the incoming attack is being prevented, or the attack is being prevented. Sometimes it's very agile and jumps on top of your defense, but it barely happens. But in serverless, you pretty much lose all of that because you don't have an internal network. You might have a private network for yourself, but you don't own it. I mean, you cannot put controls there. It's not yours. It's the cloud. And you don't know where the attack is going to come because, it could be an email. How do you protect that? So in this talk, I'm going to show you a different type of injection attacks, or it's going to be the same injection attack, but over different areas and events that happens in the cloud. So sorry, forgot. Remove the logo there. So just so you understand how it actually works, then when your code needs to run, or the code needs to run, the cloud provider, which could be any of the big ones, GCP, so Google, IBM, Microsoft, SAP, AWS, and they spin up a container. So this container is out of your control, really. It's not like you can connect to the container or you can decide what's going to be there. No, it's not your container. The container randomly spin up for your code and runs the code that you decide that you want to run for this event. So what actually happens is that the container itself is a read-only environment, apart from the /temp directory. So whatever you want to process, you're gonna do it in the /temp directory because it's the only place that you can write stuff or process stuff into. So in the attacker perspective, this is a nice place to look at, right? Okay. The event triggers from different event sources could be an email, a log, an API gateway, an MQTT, which is an IoT protocol file that was changed, an authentication service, and so on. And the source code that you wrote for this specific function is going to be stored under /var/task, or link to it under /proc process ID CWD. So your source code is also resides in the container. This is also a nice place to look at if you're an attacker. Another important and interesting stuff, depends what side of the attack are you. The environment variables are located in the environment. They're built in there, and you can call them with the end process. And what happens is that when this container spins up, the cloud provider takes the policy or the permissions that you gave the function and translates it into a temporary token. And this token values for a couple of minutes, depends. It could be even for a couple of hours, and it's going to reside inside the environment variables. So if someone can access the environment variables, they can actually impersonate to the function. So if I am somehow I gain access to the container or to the function with an injection, code injection, command injection, whatever I have, and I can steal the environment variables, I can run from my own computer at home with the same permissions that the function has, and I can do whatever the function has. Okay. So just so we understand how the policy works before we move on to see how things go bad if you do it wrong, I have this very short function. What it does, it's a code of a function that is triggered via an S3. S3 is a cloud storage for files, or a blob if you're in Azure, and the trigger. The file upload, file download, whatever that was, file delete, triggers a function. Now this function, all it knows is that it got an event, it's literally a variable called event from the cloud, and then you can do whatever you want with this event variable, argument. You don't control anything else. But inside the event argument, you're gonna find the records and the S3, and you can get the file name under bucket name, the bucket name under bucket name, and the file key, it's called key, and under object key. So now that I have the buckets and the key, what I can do is call an API, an AWS API in this case, which is called get object. And all I have to do is give the function or this API the bucket name and the key name. Now, if my function has permission to do so, it can go and grab the file. Okay, so the best way would be to do something like that. So the policy for the function will be very limited, and we'll tell the function, well, you can only do S3 get object, which is what I actually do, but you can also only do that on this specific bucket, which is what you want to do if you're a developer. But most of the time, we end up like this, which means, well, you're limited to the bucket because I know what bucket I'm working on, I mean, from the developer perspective, but I'm not sure if I want to download the file, what it is translated to in terms of API. So I'm going to do, in terms of actions in the policy. So I'm going to put here wildcard, which means that in this case, the function can do whatever it wants inside this S3 bucket. So it can actually delete the bucket, change policies there, upload file, delete files, download file, whatever you want. But in some cases, we're going to get something like that, which is where it really gets interesting. Because if you go to Stack Overflow, or even in some cases to the documentation of the cloud provider, you're going to find this permission, which tells you, well, we don't know what you want, or we don't know what bucket you want, so let's just put that and tell the function, or give the function permission to do whatever it wants over the S3 service, which means not only it can do whatever it wants inside as like an action, like delete, upload, and so on, it can do that on any bucket in the account. So if my function, even though it does always get the same event from the same S3 and will originally, or in the valid case, it will go to the specific bucket that I'm working with and download the file. Potentially, it can do whatever it wants. It can go to a different bucket that unrelated to the application and stores even internal information and get the information out of there, change the policy of the bucket and make it public so everyone will see it. So this can end up in really a very serious breach in your organization. And I mean, if you do it and something bad happens, you're fired for sure, but it could be even legal actions against you. I don't know. It depends on how you did it. I mean, okay. So after we established all the grounds, what we're going to do now is I'm going to go and start taking services that are available in the cloud and are not very common in the traditional monolith applications and see how through these events I can still cause damage using injection attacks. So I hope you know injection attacks. It's not like limited to a specific injection. It could be code injection, command injection, SQL injection, whatever injection that you want. Anything that transfer bad input into the cloud. All right. First one is going to be the more maybe similar to the traditional application to start with. So what I have here is a setup that has a Slack chatbot that interacts with the user. It could be support, sales, whatever you want to use your chat. It's very common to use chatbots on serverless because whenever someone sends an image, you can just trigger a code that will process whatever you need, and that's it. You don't have to run it idle for the entire time. So what's going to happen is that the user interacts with Slack. Slack is configured to send the event to a Lambda function through the Slack API to the API gateway of the organization. And then it's going to trigger the Lambda function, which is the function that runs the code, which is going to write the message and the reply to the DynamoDB database. It's a NoSQL database for records. And then it's going to go back and send the response back to the user. Okay. There are no limitations there. You can do whatever you want in terms of inputs. And we're going to target the Slack channel. All right. Let's see how we do that. So as I said, I presented those demos on DEF CON, so you're going to see some background related to the event. So here I have the channel that I'm interacting with. It's just a chat bot that I'm sending, has some machine learning, or actually a lot of ifs, or actually not so many ifs, just like 5. And I'm going to interact with it. And as we know in the security world, it's not like we know what's going on behind the scenes, so we have to do some trial and error and find out if it's vulnerable. So let's say I figure it out, and there are ways to know that, maybe from GitHub, maybe from, again, trial and error, seeing source code or whatever, maybe internal knowledge. Let's say I found out that this function is vulnerable to a specific, or has a specific library that is vulnerable to code injection. Now, I knew this vulnerability or libraries that the function is using. I went to the internet, Google, and found out some nice exploits there. So basically, it's a prepared exploit, only I modified it a little bit to attack a Lambda function rather than a server. Because think about it, there is no server. Where I'm sending my code is not going to live in the server. It's just going to run inside a read-only container, which is a single-purpose container, and it's going to die right after I send the request. But nevertheless, I'm going to try. So what I'm going to do is I'm going to run child process.exec, so in Node, which is a very common backend or runtime for Lambda functions. I'm going to start a child process and run curl. So I just split it up. So Slack would not translate it into a link. And then you can see I got it here. You can barely see, but I got it here in my computer. This is just an HTTP tunnel in my own computer. So I can receive requests from the internet without having to have a static IP address. So now I did the test, it worked, now I want to get some information. So what I'm going to do is I'm going to change the /tab there to another command, which is ls. Just because I want to know what's inside. And you can see that I got the index.js, which is the standard name. You can do whatever you want, but it's the default name for the handler or the file, the original file that receives the event. So now I want this file. Even though it doesn't reside on a server, it still gives me a lot of information because I know what the function is going to do. So I'm going to send and replace this now with cat index.js. So, and just in order for me to get that through HTTP, I'm going to wrap it up with base64, right? Because I want to be able to send new lines and CRLFs into my computer, and I got the base64. Let's fast forward. I got this into my computer. I'm just gonna copy that now and decode it on my computer. echo base64 pipe base64 decode. That's it. What I have now on there is the source code of the function. It's now in my computer. I can investigate what I want and see what happens. So first thing that I notice is that the function interacts with Slack, which I knew already, but now I know how or what code it uses to interact with Slack, and I can imitate that. So we'll see in a second how I can use that. I can also notice, if you can see here, I also notice some environment variables called bot token, and channel. So I can use those. Even though I don't know them yet, I can get them, but I can just use them as is. But what I'm going to show you now is the most important part, is that, as you can see here, there is a var DynamoDB equals new AWS.DynamoDB. And one line above is AWS equals require AWS SDK. So the function uses AWS SDK, okay? Which also resides automatically in the environment. And it uses DynamoDB, which is a variable name for using the DynamoDB service. One line beneath that, you can see that the DynamoDB put item, which is what the function is doing, is taking my conversation or my message and the response that was generated for me. And as you can see, username, timestamp, message response, and writes it into the DynamoDB database using the put item API here. But we already saw that the developer wasn't really a security person, and he put some wildcards in there. So what I'm going to do now is I'm going to prepare a specific exploit that will take all this information that I got, and let me take you through it. It's not very complicated. I'm going to do a require because I'm not sure exactly where I'm going to follow in the code. It was already imported or not. And then I'm going to do a var HTTP so I can send an HTTP request. And I'm going to do a var new DynamoDB document dot scan. The difference between scan and put item is that put item does what it needs to be doing to write into the database, and scan basically scans the entire database and pushes or gives the output of the entire database out. And then I don't need to use the tunnel anymore because Slack, the function, can interact with Slack, right? So I'm going to make it even nicer for me, and I'm going to use the same environment variables that the function is doing, and I'm going to send an HTTP request into Slack API. Again, all the information is already there. So when I sent that, you can see that I got the entire database dump into my Slack channel here. And all of that, and I also changed the icon just for fun. But again, this happens only for me. It's not like it's going to be persistent and anyone else going to have it. It ran once and that's it. The code died, but for me it's enough. I got the entire database or a part of it. Maybe the function is limited for, most of the time they are limited for 5 seconds and I cannot scan an entire database. So I can do it in chunks. But I got the entire database here, and that was just because the developer put a wildcard in the function actions. Okay. So we saw how we can do it through an API, which was through a third-party application. It's very common in serverless. It's not uncommon in regular application. Now we're gonna slowly get into things that are more related to serverless specific or traditional or serverless environments. So the second part is going to be cloud storage. So what's going to happen here is that I'm going to upload a file into a cloud storage. So the application wants me to upload a file, and it takes the file and uploads it to a cloud storage through some JavaScript in the client, and that triggers a function. So to process my file upload. So what I'm going to do, and I'm going to do that, I'm actually going to use a very secure, normally secured environment where I get a signed link to my specific bucket, which I can use for 2 minutes only to upload a specific file that I requested previously. So sounds secure. It is. It's not the problem. The problem is that the function that's going to process that one has too many permissions, and two is not validating anything, and I can just put some injections, command injections in the file name. So the process is that I'm going to call an API gateway and then get a signed link from the Lambda function, and then I'm going to upload it directly to an S3 bucket, so not going through an API gateway. And this is going to be triggering a function, and I'm going to target this part. So everything on the left is not important for me. And there are some limitations. Basically, I don't know why they did it, but the only limitation is putting a slash in the file name. And that's only because it's going to put you inside, like split it into a directory. So it's going to maybe interfere with your payload. It's not like it's unacceptable. So let's see how we do that. Yeah, already open. And okay, so this is, I'll introduce you later. This is a vulnerable application that is written entirely on serverless. So this is an application like an ecom, but you can see there is also leave a feedback here. So I can send a feedback to the website, and I can also attach files. Now I open the developer tools, and you can see that when I uploaded a file or selected a file, I got an attachment. This is what I'm sending, an attachment, and I got a response, which is a signed link to a specific bucket in the cloud, which is configured securely. I mean, the bucket is not public. I cannot upload, I cannot upload it directly to the bucket. I have this signed link, and this is the entire thing I can use. But the function that is going to be triggered is not doing enough. So what's going to happen is that I'm going to now do the same thing, only I'm going to change the file name to something that will do a curl, as we can see. And this is going to be a curl into my computer that is going to send me the environment variables, which we discussed. That's it. And pipe base rapid. That's it. And it's need to be a PDF for that reason, so I can just put a .pdf at the end. Okay. Let's see. So I uploaded, I got a signed link, and when I click send feedback, it's going to actually upload it to the S3 bucket in a secure way. But it triggers the function, and the function wasn't secure, so I got the base64. And now what I'm going to do is, again, I'm going to decode that environment variables, or base64, and get the environment variables. These are the environment variables of every Lambda function, unless you added some of your own, but this is the default one. And if you can see here, there are some interesting parts. So what I'm doing now is I can use environment variables to use them, but what I'm doing actually is I'm writing the credentials under the default location for AWS credentials in the computer. So whenever you run an AWS CLI command, it goes to that location and try to find a profile. I call the profile DEFCON because it was a DEFCON conference, and I only need some of them, which is the default region. I don't even have to use it, but I use it for misconfusion. The session token, the access key, and the secret key. And these are the things that live in the environment variables. I store that, and now I don't need the application anymore. I can now, from this moment on, I can interact with the cloud, or with the account of the cloud, the cloud account of this application, directly from my own computer using this profile. And what the application is going to see, or what the organization is going to see, is that their function is doing some weird stuff. They're not going to know it's me. I'm using the environment variables of the function, so I'm basically the function. And now I can use AWS CLI, which is provided by AWS, of course. And what I'm going to do is I'm going to do an S3 ls. Ls is just listing the entire S3 buckets, and you can see I got the entire list of S3 buckets. Some of them interesting more, some of them less. I don't know what permission I have. I can just try. There are tools that let you try just running AWS commands and see what you can get. So I want a specific one, which is the DVSA receipt bucket, and I'm gonna use the profile, and I'm gonna see there is a folder inside, so I'm gonna get inside the folder, and there is another folder and another folder, which is basically the date. And you can see that there are two files there. So now I want to get a specific file, which I'm going to use a different CLI, which is getObject. We see that before. I'm going to give it just the bucket and the key that I need, which is the full path to the file. And now I'm going to download it into my /temp receipt file. And I actually got a file from the S3 bucket, from a secured bucket, just because I had the environment variables of a function that has permissions to interact with it. And you can see that I got someone else's receipt. Now what I'm going to do is I'm going to maybe like whatever, I have the permissions to do that. Now I don't need to go through the application. So I'm going to make a fake receipt, upload it into the same cloud, because now I can do that, and then call the support service and said, hey, I placed an order, I didn't get anything, and they're going to see the receipt and going to send me. Of course, this is just an example of a small thing that I did, but actually I could delete the entire data they have in the account. So this is like something more problematic, or maybe they have a backup, so I can just publish it and then being famous. And then all right, so we did that, and now we're going to use an authentication service to cause an injection attack. So again, all the examples here are AWS, just because they are usually they're basically a rule in the market, and I agree with that actually. Their solution is best. So I forget to mention, it's disclaimer, it's not AWS's problem here. Right? Everything that I show is because someone misconfigured their code and someone wrote a bad code. So all the problems that you're going to see here are not a problem of the provider, of the infrastructure, but I'm going to maybe target the difficulties or the struggles that the developers in the organization have to cause some damage through maybe, and this is what we get from our customers and people that I talk to, unsuspected origins. So someone is not used to the thought that maybe they can get hacked through an email or an authentication service, because they also lived a lot of time in the traditional application and they're expecting requests and responses from an API. Okay. So this scenario, what I'm going to do is I'm going to use Cognito, which is an authentication service directory of AWS. And what's happened here is that when I log into the application, it automatically routes me through the Cognito service to get a token, and then I'm going to get into the application using this token. But for some reasons, and this is an actual reason, I mean it's a good reason also, when I authenticate, the organization wants to run a code to verify my user, my email. If I'm registering, it could be to put some additional information inside my token. You can give Cognito trigger a code that will put some information from the database to the specific user, and they will sign it for you inside the token, so you don't have to go to the database later on because it's already in the token. So there are a lot of services where you can hook an authentication service with a Lambda function and run code during the process of authentication. So, and we're going to target, okay, so the limitation. So Cognito auto-verifies emails and phone numbers, and they have limitations of how they look, because emails should be emails and phone numbers should be phone numbers. But they also allow you to, if you want to, have custom types and have types like usernames that are not the actual maybe service or the optional type that is they're gonna validate, but you can still use it for your authentication. So I'm gonna target the authentication request to Cognito and maybe, or not maybe, but basically get some damage done in the cloud. It's already open. All right. So this is the authentication service. You can custom it if you want, if you're a developer. And this is the admin, all right? Just log in as an administrator. I have access to the admin section, and I can list all the orders in the application. This just for reference. Now I'm gonna create a new user, which is a non-admin user. So I'm just gonna register here. And then I'm gonna get a code to confirm my authentication service, and I can log in, and now that I'm trying to access the admin, I'm not authorized. All right? It's not client-side, it's also client-side. So here I tried to get the admin by force, and nothing came up. So just to show you, you're unauthorized. Now, so I've prepared, so again, trial and error, I found out that this functionality is vulnerable, and we'll see soon how. I prepared a payload that is very hard to see. And let's see. I hope okay. So basically what I'm doing here, it's in Ubuntu, so I don't know how to zoom in right now. So basically what I'm doing is calling some AWS SDK that is going to send an email. Sorry, not send an email. This is the next one. This one is to set me as an admin user. And let's see if I mark it there. Admin, set user password. And then I'm going to change the password for the administrator. This is an API that exists. And also, just for myself, I'm going to put myself in the administrator group. This is also open source, everything. The bucket is open, so you can just either come to me or look at the video later, go to the bucket and download the payload so you can see for yourself. Basically, this is what I'm going to do. Change the password for the administrator and myself to an admin. And this is a command that I'm just now doing. All I'm doing right now is I'm wrapping this payload inside. I'm wrapping this payload, and then I'm going to put it in a remote host. Just uploaded. I have all the libraries that I need to use. And then, now let's go to the attack. So I'm going to register again. Domain does not exist. I just put a typo in the domain. This is how I found out that it's vulnerable, because I got the domain does not exist. So they actually someone verifies my domain. So wait, before registering, I have verb, my help, and I'm going to put username, which has the payload to go and fetch the exploit that I had. So it's going to do some cd to get inside the /temp directory, because I cannot use slashes. And then I'm going to download the remote host, the payload from the remote host, and then I'm going to untar it into the /temp directory. And then I'm going to run, I don't know if you can see that, but it says here python.py into the file. Space y.py, which is the file. And then I sent myself some notification along the way to see that things are actually happening. Okay, so I got a URL and admin, password changed, and let's see. So now I'm going to log back in. I don't know, I'm nervous that it works, it's recorded. Now I logged in with my regular user, joking, and I got all the admin information. Okay? I changed myself and I moved to a group that is called administrator. And now, which is the nicest part in this case, I don't know, because maybe I don't know the group of the admins, I'm going to log in with the password that I set to the administrator. And now I logged in with a different password, which is someone that I set. Now these APIs exist. You just need to be very careful with what you're doing. But sometimes you need some admin capabilities in the cloud because you're an admin, you want to control things. But when you give the function permissions to do that without checking that actually, or making sure that you're doing it correctly or manually, that becomes a problem. All right, we have 15 more minutes, and I'm going to show you the last example. Because I have 10. Okay, so the next one is email. Let's keep it short and just go to the video. All right, so I have a call for papers, and I'm going to submit a paper here. Regular innocent submission. And I'm going to get an auto reply because there is a Lambda function behind. I don't have to tell you again. That tells me, well, thank you for your submission. We got it and we'll be in touch. Now what I'm going to do is I'm going to send a malware. Just a regular malware PDF, a regular malware. Like, it's my everyday, I'm doing that, regular malware here. So I'm sending a malware, just a PDF with a malware here. It's not an injection attack. It's just to get some information out of that. And I actually got a response that says, hey, hold up, we found a malware inside your, it's not an actual, right, but we found a malicious submission. You can click here to review your submission. It actually works because I built it, but that what happened, and this is why I thought maybe they run some code behind the scene to check some stuff. And then I prepared a payload, that what it does is two things. One is gonna send an email from the organization, and I'm going to send it to myself just to see that it works, but I couldn't actually send it to anyone. But again, I always do two things. One is nice and one is very nice. And the nicer part is that I'm going to take the bucket, which is highly secured with all the submission, and I'll show you, and change the policy of the bucket to be open. Just because someone configured the bucket extremely well, but someone else configured the function very bad. So I can turn the secure bucket into an insecure bucket from maybe a different developer, not maybe, probably going to be a different developer in some cases, could be a different application entirely. So they might not even know each other. And again, I'm going to wrap that up and upload it to a remote host, and then through email, I prepared a submission, which is, again, going into the / directory, curl into the exploit that I prepared, untar it, and then run python space x.py, which is the name, and I did the pound key there to make the rest of it a command. So now I'm going to upload it. And first I'm going to show you the bucket is secured, so I don't have access to it, even though I know the address. And now I'm going to submit my malicious file name, or submission with a malicious file. And again, I submitted myself some notifications, so I'll see that things happen. Phishing email, bucket hijacked. Okay, so first of all, I got two responses. The first one is, okay, thank you, we got your submission. The second one is the one that I submitted from the origins of the organization, and they say, thank you for your submission. You have been selected, and click here, phishing.com, to get your honorarium for your application. They're probably going to ask me for my bank account or whatever. But as you can see, I also changed the permissions of the bucket that holds the entire submissions to be public, and I can now see the entire files. I can even download them if I want. And again, this is fun because it's submissions, but it could be more severe things that happens. And because we're lacking time, I'm not going to show you. I did it also with Alexa voice commands, so you can actually do injections with voice commands. You can look it up in the internet. I actually basically I said, Alexa, please hack. Gave a, no, I'm joking, but I did something like I gave it the information or the ID or the account ID, and then I said or true, or, and you can pipe commands, and then you can cause SQL injection if the developer wasn't smart enough. Or there's no security. You can do it with logs, with code, and basically you can do it with a lot of stuff. So two things that I'm going to mention is that I started the OWASP Serverless Top 10, which is, again, it's open source. You can go and take a look, read the report. We have a first report, and you can participate. And the second part, you can also open source. You can download the then vulnerable serverless application, and you can practice for yourself. It's open source. You can actually, if you have an AWS account, you can just go to the repository and do 3 clicks to get it installed. So no configuration, 0 configurations. You have it up and running. This is recorded, so I know I said it and it's recorded. Don't install it on anyone's production account because you'll get fired, if not go in prison. There's just a bunch of resources that are vulnerable to do whatever they want in the account, so don't do that. Thank you very much for attending this talk. Just in time for questions. 2 minutes for questions. Yeah. Sorry? Oh, the repository? It's recorded, but okay. github.com/OWASP/DVSA. Or, I didn't put it here, you can just look it up. Okay, any other questions?
You talked about trial and error on one of the
Yeah.
How much time and how much trial and error, and how do you backstop that to learn iteratively, or you just...
Okay, so first of all, it's very difficult to even know that there is a Lambda function behind. There are some ways, or another cloud's function. There are some ways to know. They involve usually around headers, but this is only if it's an HTTP request and you can see the headers. If it's an email, there is no way to know. You can just try. So if you suspect a function or an application is built on serverless, you have to know some payloads that will target functions and try them like you would do in regular applications.
All right, that's it.
All right.
Thank you.